We said in a right angle triangle, ratio of sides is a function of theta, function of angle between the sides. We call this adjacent side. We are using the symbol x. And this vertical side is opposite side of angle theta. We are using symbol y for it. Longest side is called hypotenuse. We said the ratios of sides y by r depends on theta, and similarly x by r, adjacent side divided by hypotenuse, depends on theta, and of course the ratio of vertical side to horizontal side or opposite side to adjacent side also depends on theta. These are different functions. When theta is changing, y by r changes differently from how x by r changes, and y by x changes differently from how x by r changes. So these are different functions. The dependence of y by r on theta is different from the dependence of x by r on theta, is different from the dependence of y by x on theta. So we are going to name these functions. The names of these functions I am going to write now. So here, these are the names given. Opposite side to hypotenuse. The ratio opposite side to hypotenuse is now called sine function of theta. Or we will write short and sweet as y by r is equal to y divided by r is equal to sine theta. This is the short form. And x divided by r, that is the ratio of adjacent side to hypotenuse. The ratio of adjacent side to hypotenuse is called cosine function of theta. Cosine function of theta, or simply we would call it cos theta. In the short form, we would call it cos theta. And the ratio opposite side to adjacent side, that is y divided by x, is called tangent function of theta. Tangent function of this angle theta. Or in the short form, we would write it as y divided by x is equal to tan theta. So these are the three ratios that we are going to study in trigonometry. Y divided by r, that is the ratio of opposite side to hypotenuse, which is sine theta, and the second ratio is the ratio of adjacent side to hypotenuse, which is cos theta, and the third ratio is the ratio of opposite side to adjacent side, which is tan theta. So these are the three ratios that we are going to study. The reciprocals of these ratios also have names. Let's write down those names also, names of those functions also. Reciprocals of these ratios. What are those ratios? Opposite side to hypotenuse ratio, sine theta, that is one ratio that we wrote down in the previous page. And the second ratio is the ratio of adjacent side to hypotenuse. We call it cos theta. And the third ratio, the ratio of opposite side to adjacent side, we called it tan theta. Let's write down the reciprocals of these ratios. Reciprocal of this ratio that is r divided by y, the ratio of hypotenuse to opposite side. And similarly, look at the reciprocal of second ratio, cos theta. The reciprocal of cos theta, r divided by x, is called secant function of theta. Or in the short form, we write it secant theta or sec theta. Which is, of course, the reciprocal of cos theta. Secant theta is reciprocal of cos theta. Similarly, the sixth ratio is reciprocal of tan theta, that is adjacent side to opposite side ratio, is called cotangent function of theta. Cotangent function of theta, or in the short form we call it cot theta. X divided by y is equal to cot theta, is reciprocal of tan theta. So these are the reciprocal ratios of the first two functions. This is the reciprocal of sine theta, and here is the reciprocal of cos theta, and here is the reciprocal of tan theta. These are the 6 trigonometric ratios that we are going to study. We are changing as theta, we are saying as theta is changing, the ratio y by x, y by r is changing, or we can say in other words, sine theta is changing. Sine theta means sine function of theta. Cos theta means cosine function of theta. Tan theta means tangent function of theta. So here, theta changes, sine theta also changes. When theta changes, this ratio x by r or cos theta changes. When theta changes, this ratio y by x or tan theta changes. How do they change? What are their values at different values of theta? As theta increases, what happens to sine theta? Sine theta also increases or decreases? As theta increases, what happens to cos theta? Cos theta increases or decreases? What is sine 30 degrees equal to? When theta is equal to 30 degrees, what is this ratio equal to? Or when theta is equal to 45 degrees, what is this ratio equal to? When theta is equal to 60 degrees or 15 degrees, for any value of theta, what are these ratios equal to? How do we find those ratios? That we will see now. So we have total 6 trigonometric ratios here. Sine theta, cos theta, tan theta, cosecant theta, secant theta, and cot theta. These are the 6 trigonometric ratios that we are going to study. Now, in order to study how these ratios are changing as theta is changing, let's take a unit circle. Let me draw a circle here. In order to understand how these ratios change as theta changes, let me draw a circle. Let's take center of the circle as the origin of xy coordinate system. Let's say this is x-axis and the vertical line passing through the center of the circle is y-axis. This is the center of the circle. Let me say this is x-axis, horizontal line is x-axis, vertical line is y-axis. With this circle, it is easy for us to understand how the ratio changes when the angle inside the right angled triangle changes. Let's also draw a right angled triangle here. Alright, look at this right angled triangle. In this right angled triangle, let's say this angle is theta here. Let me call this point, this vertex as A. This vertex, which is in contact with the circle, is called B. The adjacent side of angle theta is x. The opposite side of angle theta is y. And the hypotenuse is r. As theta increases, y increases, x decreases. Look at, draw one more right angle triangle. Look at this right angle triangle. Now, angle has increased, x has decreased, y has increased. R remains same, that's why I have drawn the circle here to keep R constant and y changes, x changes. So R is the radius of the circle, hypotenuse of a right angle triangle that we draw inside this circle is R, radius of the circle. So radius of the circle is same, but y is changing, x is also changing. Look at these two right angle triangles. One is OAB, the other right angle triangle is OCD. Look at angle. So angle, let me call this angle theta 1 and this angle as theta 2. Theta 2 is greater than theta 1. Look at the figure. Theta 2 is greater than theta 1. Angle has changed, angle has increased. When angle has increased, opposite side length has changed, adjacent side length also has changed. OC now is less than OA. Adjacent side length has decreased. Similarly, opposite side length has increased. CD. Look at CD. CD is greater than AB. So as theta increases, x is decreasing, y is increasing. Hence, the ratio y by r increases, x by r decreases, and y by x increases. Let's look at angles less than 90 degrees. For the time being, we are looking at the cases when angle is less than 90 degrees. Theta, of course, there is less than 90 degrees. Look at theta. Theta 1 is less than 90 degrees. Theta 2 is also less than 90 degrees. So below 90 degrees, when theta increases, the ratio y by r increases, the ratio x by r decreases, the ratio y by x increases. It means as theta increases, y by r means what? Y divided by r means sine theta. Now we are calling this ratio with the name sine theta. Sine theta increases, cos theta decreases, and tan theta increases. This is when theta is below 90 degrees. When theta is below 90 degrees, this is what we observed in this example. So for theta below 90 degrees, let's find out the values of sine theta, cos theta, tan theta for different values of theta. You don't have to memorize anything. You don't have to mug up anything. You don't even have to mug up the values of sine 30 degrees, cos 30 degrees, tan 30 degrees, sine 45 degrees, cos 45 degrees, tan 45 degrees, etc. Right? Let's see how to find the value of sine 30 degrees, how to find sine 0 degrees, sine 60 degrees, sine 45 degrees. Similarly, the other ratios, cos theta and tan theta for different values of theta.